Here we have a motherboard that's coming all the way from India. All the way from India. It came in for repair, and the customer mailed over the motherboard only. Looks something like this. And I can tell you, the customer already sent over 6 million emails since that package arrived. He actually sent emails before the package arrived. He sent one email saying that he's going to ship the motherboard. My apologies before raising the ticket in a hurry. I had already sent the package through speed post from India. I would appreciate if you can make a video on it as well. It has reached your location. Please accept. And the customer did not only send messages on our ticketing system, but also via email, via YouTube, via Facebook. And we're going to work on it today. Okay, let's take a look. We're not going to be able to fully test the motherboard without an actual laptop. So we're going to see if we can find anything wrong with the board. If we can, we're going to fix it, and we're going to invoice the customer for a full repair. Okay, so let's start with where the charger plugs in, right here, via flex cable. And let's quickly measure and see if we have a short here. Meter in diode mode, and we do not have a short. All right. I mean, I can tell the board was worked on before. We do see signs of flux here. Or maybe signs of liquid. So far, I do not see that any components were changed on the board, but we still did not finish looking at the board. Zero 0.5, 0.5, 0.5, 0.5, no problems. And this looks like overfill by the factory. Okay, let's flip the board right where the DC connector is. And what do we see? We see nothing. Maybe the board suffered some biryani, nahari. I don't know. Oh, whoa, whoa, whoa. Look at this. And that's definitely a prior repair attempt. Solder blobs here. Whoa. We have a problem with the MOSFET. No short on gate, no short on source, and no short on drain. What if we check between source and gate? We have a short. All right. Drain and gate, we have a short. Okay, so this is not good. What about the current sense resistor? It's measuring 0 ohms, which is good. All right, let's continue with visual inspection, and then we'll come back to this. All right, and no issues. That's the only problematic area I see on this board. Let's go ahead and replace this MOSFET. And we're gonna clean up this current sense resistor. And I'm using a very narrow nozzle. I do not know if that will work, but let's try. I was working with 1005 SMD components, and I put this very narrow nozzle. Okay, so this guy wanna run away. The guy wanna play games. Now we're gonna have to solder a new MOSFET here, and we're gonna have to connect the drain of the MOSFET onto this current sense resistor. The MOSFET was badly burned. It fused itself down to the layer of the board. So we had to get rid of that piece. The piece was stuck onto whatever was left over from the MOSFET. Okay, so that's good. We have source, we have gate. And let's grab a MOSFET. All right, very good. And now all we have to do is run a wire from drain to the current sense resistor. And let's do one more layer, because some scientists in the comments will complain that wire is not enough. Let's do 6 folds of wires so we can save all the scientists from complaints. Right, so now we have a very good connection between drain and the current sense resistor. It doesn't have to look pretty as long as we have a connection. So we did it. Now let's check and see if we still have a short between gate and source. From here to right here. Meter in diode mode and not resistance mode. And we do not have a short between those two. Awesome. 0.4, that's amazing. Of course, 0.4. And if we test from here to here, that's good. And that's it, the job is done. We fixed the MOSFET, the layer of the drain, and we're all good. We tested all the V-core MOSFETs, and I went over the rest of the components on the board, and nothing is testing faulty. Right now I plugged a charging cable in. I want to see if voltage is making its way inside. Meter in voltage mode, and we have 19 volts. That's good. And if we flip the board, let's measure at the MOSFET here. Drain we have 19, source we have 19, and gate we have 19.6, and then perfect. So all the voltages are present. Maybe I can do this so you can see what I'm measuring. This is the MOSFET that we changed. If you look here, we are measuring 19 volts. And if you look here, gate 19.61, 19.56 here, and drain current sense resistor 19.10. The other end of the current sense resistor 19.10. That's very good. All right, that's it. We're gonna end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.